Okay, as I mentioned to you about the linked list, so if we want to remove in the tail, if we want to remove in the tail, so we will do from the first. We will check one by one from the head until the tail in order to avoid the worst case scenario. We can apply stack. So we still remember stack is remove as in first out. Okay. If Q is first in, first out, P hook. So we can also apply Q as a linked list. Yeah, we can also apply stack as a linked list. It means we combine the stack with linked list. We combine the Q with linked list. Depends on how you want to address the operation. So we can implement a stack with a single linked list. So the top element is stored as the first node of the list. So if you still remember, stack, okay, we have an element, and then we have another element, we have another element, we have another element. So the top will be the first node. Or yeah, you can also consider the first, the top element will be the last node. Okay, so it depends how you do the operation. So we will look more with other data structure. The data space ON, of course, if we have n data, yeah, it will consume n memory. And each operation of the stack, it takes O one time. So if you want to make a new data structure, and if you want to make an abstract data type, make sure that that data structure will do the operation of constant or O1. So this is an example of the linked stack. So in the linked stack means I'm going to have another class. Okay, I have this node class. Okay. So the node class, will have a slot. Okay. So these slots contain two things, which is element and next. So when we construct this class, we will create an element and we will create next. So the element means, yeah, the object of the element. Next is the object of the node. This is another class, and then when we use the stack, we will construct or we will initiate a new object. The original head is known and the size starts from 0. So the length means the size of the stack is empty. If the size is 0, then it is empty. So you still remember in the stack we have push and pop. Push means you want to insert a new element. So the new element E is inserted into the data structure. In this case, I do not use any list. I use an object. So the object is node. So that's why when we have a node like this one, yeah, it is different with list. So the node that I want to insert, so I'm creating a new node, and the element E will be insert it into head. So after I inserted the element into the head, then the size will be added by 1. Now I want to know the top of the stack. So the top of the stack means the head. So if it is empty, then let's just give the message. If I want to remove the element, first I need to check whether it is empty or not. If it is empty, then let's write the message stack is empty. If it is not, then let be the answer is the element of the head. And then head, the new head is the next element. So we know linked list, something like this one. So we will connect like this one. If we remove the top, so the new head will be this one. If we remove the top, then the new head will be this one. So the next will be the new head. So the size can be reduced by 1. So we will return the answer. So this is the linked list with stack. We can use queue as the linked list. So we can implement queue with a single linked list. The front element is stored as the first node, and the rear element is stored as the last node. Again, the space is on, and the operation of the queue, the operation means the insertion and the removal operation. The insertion operation, it gives you 1, and the removal also gives you 1. Okay. In the mid exam, I think some of the students still confused, okay, between the on and then I don't know why many students when you write the code for the Euclidean distance, okay, some of you write O log n. I don't know why you suddenly mention log. Okay. So log means you can reduce the computational cost by half. So until now, we still have not learned anything about the log, but we learned only about binary tree, binary search. So that's the log n. But other operation, we just have O1 and On until now. So those kind of operation from stack, queue, linked list, all of them are O1. Or the worst case is On. So this is the code for the link queue. Note, okay, this is just you can refer to the previous note. It's the same. And then when you construct this object, you will have head, which is starting from none. The tail, you can start with none, and the size is 0. The length means I want to know the size. Empty, I want to know whether it is empty or not. First, the first means the head. Okay. So if it is empty, then okay, Q is empty. But if it is not empty, I will return the element of the TQ. TQ means removal. I want to remove. Then I would like to check if the Q is empty or not. If the Q is empty, then Q is empty. If it is not empty, then we will get the element of the head and then put it into the variable answer. After that, the new head will be the next element. And the size will be -1. Now you will check whether it is empty or not. Because after you remove, let's say I have only 2 nodes. So if I remove this one, there's only remaining 1 node. If I remove it, then empty. So we need to have a condition. If it is empty, then the tail will be null. NQ means I want to insert a new element. So the new element means a new object. I'm creating a new node, and the node is an element E and none. None means I do not know where is the position. So I'm creating this one and check whether it is empty or not. If it is empty, then let's put the new node as the new. If not, then let's put the next as the tail. So the tail is the newest, and the size will be added by 1. Okay, so that's how we put linked lists into the queue. The second part is doubly linked list. If we learn about the singly linked list, it is single. Okay. We call it singly, it is single, but we have another linked list which is doubly. And then how we can apply the doubly linked list, and then we will learn about the positional list. So the doubly linked list, it looks like a kind of train or of vehicle which is connected. And the idea is the same. We will have node. But now, a doubly linked list provides a natural implementation of the node list ADT. So in the node, we can do some more ideas. Not only the element and next, but we also have previous. So nodes implement position and store the element, link to the previous node, and link to the next node. So it is an ADT, not using a list. And there will be a special trailer, or this is the last element, and header. This is the first element. So every of those elements will be in between. We call this is a node, it is another node, it is another node, it is another node, or sometimes we can call it as a position. So the doubly linked list, the idea is almost similar with the singly linked list, but we have previous as one of the additional part. Music player, if you use your app, your smartphone, we can use next and previous button. If we use like the browser, internet browser, we can back and forward. Undo and redo functionality in Microsoft Word, undo, PowerPoint, those kind of things we use the doubly linked list. Again, as I mentioned to you, every data structure will have 2 things: insertion and removal. Okay, so please keep in your mind. Every data structure will have two things, insertion and removal. First, let's look at the insertion with doubly linked list. So we want to insert a new node. Let's say I want to insert Q. So this is the original data. I have header. This is a header node. It means this is the first. And this is the trailer node. It is the last one. And we have 1, 2, 3. There are 3 nodes. So if we look at this one, the element is A, the element is B, and the element is C. Now I want to add a new node Q between P and its successor. So I want to insert Q between P and its successor. Its successor means this one. Between P and its successor, I want to insert Q. Then we will do a new node generation. We will construct a new node. We will add what is the element, and then we will connect. The previous element would be this node, and the next element will be this node. After that, we will remove this one, and then the next element of P will be updated here, and the previous element of C will be updated here. Then we will get a new data like this one. What about deletion or removal? We want to remove a node P. So we want to remove P from a doubly linked list. Then when we want to remove, this is a trailer node. Trailer node is the last node. If we want to remove this one, we will check what is the previous one. The previous node is T. Then let's update the next of C. So the next of C, now it connects to the trailer. And then this is the trailer node. The previous of the trailer node will be connected to C. And then after that one, we can remove it. So the doubly linked list, you can see this code. Is it a class and then node? Okay. In the node, you know from the stack. Okay. So we have some components. In this case, we have the element, we have header, and we have trailer. Okay. So the previous one, if you look at the singly linked list, if you look at this singly linked list, it is only using the element and next. So we have the node here. So we have the element, sorry, we have the element, we have the next, and we have previous. So it means I want to know what is the next node, and I want to know what is the previous node. We call it doubly because we have two more elements, two more connectors, which is next and previous. If we use singly, it means singly linked list. It means we have only next. That's why we call it single. If we use doubly, we have two things, next and previous. That's why we call it double. Doubly. So when we create the node, we have the element, we have the next, we have previous. When we create the doubly linked base, so the constructor contain header, trailer, and what is the position of the header and what is the position of the trailer. As you can see, node contains three elements: none, none, none. Why there are three? As I mentioned to you, because we are using the doubly linked list, so there will be three elements, which is the element itself, and then the previous and the next. So that's why the node contains three parameters. The trailer, we have also a node which is none, none, none. Yeah, because at the first time there is no element, and header there is no element. So the next will be trailer, and the previous of trailer will be the header. So if it is the starting point, then the header and the trailer will be like connected like this one. The length is the size, so the initial size is 0, and then it's empty. If it is empty, then the size is 0, then it is true. We can do insert between. What does it mean by insert between? Insert between, we have three parameters. We want to insert the element E into the predecessor and successor. So it means I have a node, I have another node, I have another node, I have another node. And if I want to insert in between this one, then this is the predecessor and this is the successor. If I want to insert here, then this is the predecessor and this is the successor. When I want to insert, then there is a new object. The new object is a new node with element E, and then the predecessor, I need to check what is the predecessor and what is the successor. The predecessor means the node here, and the successor means the node here. And we are going to update the next of the predecessor is the current, and the previous of the successor is the current. Okay, please check this one. Size will be added by 1, and then we will return the new object. Let's suppose I want to delete or remove one node. So if I want to remove one node, then we need to know what is the previous of the node. The previous of the node is the predecessor. The next node is the successor. And then the predecessor dot next will be the successor, and the successor dot previous will be the predecessor. So if I have the predecessor, node, and successor. Okay. So this is the predecessor. This is the current node, and this is the successor. Then, when I delete node, when I want to delete this node, we know that the original connection is something like this one. So the predecessor will be the node previous. Okay, so this is the predecessor. The successor is node dot next. Okay, this is the successor. Now the successor dot the predecessor dot next will be the successor. So we will remove this one and change the next of the predecessor is the successor. Successor dot previous will be the predecessor. So we will remove this one and we will update this one with the predecessor. Now the size will be -1. So we will remove this one. Element equals to node dot element. So we call what is the element here? Node that previous. So this one becomes node. Node dot next. This also become node, and node dot element becomes node. So we totally remove it. And we want to know what is the element that has been deleted. So the performance, the space used by the doubling list, it is ON, of course, because there are some N elements. And the space used by each position of the list is O1. And all the standard operations run in O1 time. So we learn from the stack, okay, and Q singly linked list and doubly linked list. All the operation runs in O1 time. That's why people propose this kind of data structure. If it is necessary for your project, yeah, you can try to apply. There is a concept about positional list. What is positional list? So the positional list is, you know, in the list, you can know what is the position or what is the index. This is index 0. Okay, this is index 1. This is index 2. In terms of list, yeah, we can know the index. So we will also create an ADT. How to create this ADT, abstract data of the positional list. So to provide a general abstraction of sequence of elements with the ability to identify the location of the element, we use the positional list. A position acts as a marker or token within the broader positional list. And a position is unaffected by changes elsewhere in a list. A position P is unaffected, means it is not affected by changes in any position in other lists. The only way in which a position becomes invalid if an explicit command is issued to delete it. So if the position P is deleted, then it is removed. So a position P is a simple object supporting the following method. For example, I want to know the element. P dot element means I want to know what is the element at the position P. So if you look at the list at index 0, index 1, index 2, index 3, and so on. So I want to know what is the element of index 1. Then usually we just, let's say, A at index 1, something like this one. Now we are going to make that ADT. So in this positional list, we can define what is the first. It means the first element of the positional list. What is the last? We can look at what is the last element of the positional list. If the result is known, then L is empty. If it is known, then L is empty. We can also check what is before the P. It means if I have element, so I can know what is before this position. I can know what is after this position. And then is empty. It means I want to know if this L, okay, if I have L, whether is L empty or not. And I want to check what is the length of the L. And we can do the iterator. You still remember iterator? The iterator is similar like for loop, but we will do for every element, not like for loop. We will do every element at once, but using the iteration or the iterator, we will wait something. For example, if we call next, then we will go to the next element. Okay, last time we already learned on the first part of the Python. So in the positional list, we can add an element in the first or in the front. We can add the element at the last position. We can add an element before T. We can add an element after T. We can replace P with E. We can delete a position. So this is an example. The table shows a series of operations of initial empty positional list. So L is empty. At the first time, L is empty. So to identify the position, variables such as P and Q are applied. So just for this example, I would like to use P, Q, R, S. For each exposition, the list contents are displayed with subscript notation to denote its position. It means that subscript, do you know subscript? Subscript means if you type something like this one, 8, this is subscript. So in the below part. We can also put superscript. Superscript is the upper. So we call this is superscript if it is in the top. But if we put in the bottom, we call it this is subscript. Now let's look at this one. At the first time, L is empty. Now L at last 8. I want to put 8 at the last of the L. Because L is empty, then L has a new element 8, and we put P as the position. So we have 8 and the position is P. Now I want to know what is the first position in the L. Okay, the first position is P because we have only one element. Next, I want to add after. So after P, I want to add a new element 5. It means after P, I want to add a new element 5 and let the position name is Q. So after P, let's say I want to put Q as the position index. Then 5 is added and then the position is L dot before Q. So before Q, I know that it is P, and yeah, we just give the position. We have add before Q, and the element is 3. So what is Q? Q is here, and before the Q, I want to add 3. So let's say, yeah, I have the P, Q, and then I will continue the position with R. So the new element 3, now the position I want to put as R. I want to know the element of position R. The position R means, okay, the element is 3. I want to know what is after P. After P, it is R. I want to know what is before P. Before P means nothing. So it is known. I want to know what, I want to add a new element 9 at the first position. So what is the first position? Yeah, if it is a positional list, so the first position will be here. So 9 will be added, and let's say, yeah, after I have P, and then I have Q, and then I have R, and then I have S. So let's say the element 9 will be added, and the position is S. Now I want to delete. I want to delete the last of L. The last of L is 5. So I will remove 5 and the new L will be 9, 8. I want to replace P with 7. So I would like to find where is P. Okay, this is P. The original value of P is 7. Now, sorry, the original value of P is 8, and I want to change it to 7. Now it becomes 7. Okay, so this is the positional list. We can make this positional list like this one. The positional list is inherited from doubly linked list. Okay, do you still remember? This is inheritance. Okay, so if you understand the object oriented, it will be not difficult to understand. Where is doubly linked list? The doubly linked list is the one that we learn from here. This is the class doubly link base. And then all these properties now is inherited into this positional. It means we can have node, we can have the insert between, we can delete, we can know the size, and etc. So we have another class which is position. In this position, we have two parameters, which is container and node. So the container will be in the variable container, and it is a node that will be in the variable node. So the element means I want to know what is the element of a particular node, and then equal. The equal means I want to know what is the node in the position node. If NE, it means not equal. So this is to validate. So it is whether P is not an instance of position, and then if P is not belong to a container, or if P is not in the next node. This is just for the validation for every object generated. And then make the position. To make the position means if the node is header or if the node is trailer, then let's make it as node. Otherwise, let's make the position as the node. The other thing is it is not complicated, you know. First, okay, I want to know the first. So if I want to know the first position, then call the function make position and look at the header.next. I want to know the last. So I want to call the make position here, and then I want to know what is the previous of the trailer. So I want to know before. So before means I want to validate. Validate means here. I want to check whether the object is a position and the container is available, and I want to know whether the next node is available. After I validated one, then let's make position node dot previous. After it's referencing, first I will validate it, and then I want to make the position of the next of the node. I can have the iteration. The iteration means, yeah, we will do the first. We will check what is the first of the node, and then the cursor. So it will go after, or we will go next, and so on. Okay, so the remaining is similar with the one that I mentioned to you. Everything will use the make position. So if it is insert between, we will use super. Do you still remember super? Okay, we will do the super class. We will generate the super class and then run the insert between. There are three parameters: E, predecessor, and successor. If it is at first, yeah, this is the insert between. If we do the at last, this is the insert between. Yeah, the insert between is this one. At before, so we will do the insert between. At after, we will do the insert between. And if we delete, so we just remove. If we do replace, we just replace the element and put the element into the node. Then, yeah, this is a summary. You already learned about the singly linked list. The singly linked list means I just know about the next. Doubly linked list, I can know the next, I can know the previous. There's another kind of linked list, we call it circular linked list. The circular linked list means I have next, I have next, I have next, and then after a particular space, I connect this to the head. So this is a circular linked list. I put the code, okay, maybe I don't have much time. I already explained all the codes, so please take a look on the code that I gave to you. The code for linked list, the code for doubly linked list, okay? So you can try at home. And also the code for the positional list, you can try to run it and look the details of the code. Okay. Any comments, questions? Then thank you very much. And